Okay, this is section 1.6, graphs of functions. This is the second part. The first video is getting a little long. So we're going to try to show you how to prove or show if it's an odd or even function. So I'm going to go to the end here. And to prove these things, what I'd like to do is have you set up an introduction. And then you have a body. And then a conclusion. So in other words, you tell us what you're going to show us. You go ahead and show it, and then you tell us what you did show us. And so remember that if we have an even function, I have this here, if we have an even function, we need to show that f of negative x is equal to f of x. If we have an odd function, we need to show that f of negative x is equal to negative f of x. And so let me set this up for you. So what do we need to show? First of all, this one says show that it's even. Does it look like it's even? Well, I have an even exponent, constant. That looks good. What about absolute value? Sure, absolute value will be even as well. So what we do is say, okay, we must show, since it's even, we must show that f of negative x is equal to f of x. Very simple. Okay, so what are you going to do? You start off with f of negative x and take wherever you see x here and you're going to replace it with a negative x. So I get negative x to the fourth minus 3, and I put the negative x squared plus 2 negative x, and then minus 4. So in other words, I took out this x, took out this one, and replaced it with negative x all the way through. Then what happens when I take this negative to the fourth power? Sure, it becomes a positive. What happens to this negative to the second? Sure, it becomes positive, but I still have the negative from here. So this would be negative 3x squared. This one, well, negative 1 times x, whatever it was, and you take the absolute value, still is going to give me a positive value. So regardless, this would be still 2 absolute value of x. And then the minus 4 doesn't change at all. How does this compare to my original? Voila. That's the same thing as the beginning. So I started here and I finished here. So then we just summarize, and it's kind of redundant, but I'd like you to do this anyways. Since f of negative x is equal to f of x is even. Okay, so here's kind of our intro, here's our body, and here's our conclusion. Why don't you try this one for odd and see if you can do it. Pause, and I'll do it. So we must show, I forgot the word show there. We must show f of negative x is equal to negative f of x in order to show that this is an odd function. So I start off with everyone, we start off like this. And we're going to take wherever we see x and replace with negative x. So this is 15 times negative x all over negative x quantity squared plus 3. Now we're going to see how this washes out, if it does or not. Well, in the numerator, I don't clear this negative. It's still there. In the denominator, oh, it does clear. So I get x squared plus 3. Now how does this thing compare to our original? Well, it looks like negative 15x over x squared plus 3. And that is negative f of x. So then your little summary here is that since f of negative x is equal to negative f of x, f is an odd function. Okay, so that's how you prove them. What you got to do is go through the steps, so you can't just put it here and then just say there. Show me a little algebra and see how it washes out. Okay, that's how I'd like you to prove these things, and we're going to test you on these at some point in time. So you need to be able to do that and see how it does go away. On the also, why don't you graph this one sometime and see if you can find if it has asymptotes or maxes or mins or what it does. It's an interesting looking graph. And also you can see that it's odd. I'll give you a little teaser. Looks something like this. Okay? Thank you very much. So this is the second part, and I'm sorry for the length of this lesson. Take care. Bye-bye.